we present an intuitive user interface for interactive mesh decomposition called cross-boundary brushes. Previous interactive systems allow the user to sketch directly on the desired cut boundary. Such interface provides good user control, but could be quite tedious. Other systems let the user draw free strokes on the mesh to define foreground and background regions. This interface is easy to use, however the user loses control of the cutting boundaries. Our system aims to achieve both ease of use and user control over the cutting boundaries. The user draws a stroke roughly across a desired cut, and our system automatically returns a best cut that runs across the user's stroke. To refine a cut locally, the user draws additional cross-boundary strokes. Our system provides two types of brushes, namely part brush and patch brush. This design is motivated by the observation that real-world objects contain two main types of components that merit cuts. The first type is semantic part components with protruding shapes, such as legs and arms of human models. The second type is patch components, which are flatter, such as chest character models and facets of CAD models. A common user interface is shared by these two brushes, enabling easy switching between them. In this example, the user first uses the part brush to cut out one ear of the bunny, then switch to the patch brush to cut out the I and H characters, and then switch back to using the part brush to cut out another ear. Our part brush uses the isolines of a harmonic field as cutting boundaries. First, a harmonic field driven by the user stroke is generated. Then, a set of isolines crossing the user stroke is extracted. Finally, the best isoline is automatically selected as the cutting boundary. Note that since the isolines are smooth, no post-smoothing of cutting boundaries is needed. Our system usually requires drawing only one stroke for each cut. However, in some cases, parts of the cutting boundary may deviate from the user's expectation. In that case, our system allows the user to draw additional strokes to refine a cut locally. Our part brush has several desirable properties thanks to the inherent smoothness of the harmonic field and our robust isoline selection scheme. Here the user draws similar strokes on the armadillo model in different poses, and our system returns similar cutting results for all of them. This image shows the results of segmenting the raptor model with different tessellations using the same stroke. Our part brush is also robust to noise, as shown in this example, and is insensitive to variation in the user's stroke. Our patch-based brush is designed for segmenting flatter regions. It is based on a region growing algorithm. We introduced a novel face-based surface metric applied on a filtered normal field to improve the performance of current region growing algorithms. Here we showed that a single patch brush stroke is sufficient to cut out each patch component on the armadillo model. In this example, two strokes are sufficient to cut out a facet of the fan disc model, even when the model is coupled with noise. To segment complex geometry features, the user draws more strokes to control the boundary locally. Here we show more segmentation results using our system. In summary, we have presented an efficient mesh decomposition system that is easy to use and produces better segmentation results than previous interactive systems.